Hi, my name is Tim Harper, and this is the Ceph-on-Mesos demonstration video. In this video, I'll be talking about how to install the Ceph-on-Mesos framework. We'll be doing it manually, although that's not the way you would deploy that in production. It is a rather good way to become familiar with the framework and learn it. Then we'll also launch Ceph monitors and Ceph object storage daemons using the framework. And then finally, we'll dive in a little bit into how to configure the host to connect to the Ceph cluster so that you can actually make use of them, say, in something like Docker. Some prerequisites. We do need to have Mesos installed, of course, and right here for this demonstration video I'm going to be using 3 virtual machines that I've configured. It just has vanilla Mesos installed, and I don't think anything else. I do have Mesos DNS installed as well. You could run this against DCOS, of course, but it doesn't require that. Something special about the slave configuration itself is that we need to have what's known as mount volumes or mount disk resources available. What this means is that the slave can offer a task, an entire disk, such that only that task will have access to that disk and no other task will be launched against it. This is important for Ceph object storage daemons, specifically so there's no contention over the I/O, or at least as little as we can make that. And then also that it's important that the Ceph object storage daemon has a way that it can determine its own quota. So those are 2 reasons why it's important to use a mount resource rather than a path or the root disk resource. Also, these do need to be formatted with XFS. That's a recommendation for deploying Ceph anyways. You can use Btrfs. That will work as well, although that's at the time of this recording it's considered experimental. Okay, so the first step is we need to install the framework. Now we're just going to go ahead and pull it right off of bin tray. And like I said, normally you would launch this with something like Marathon. The framework itself follows a let it crash policy, and it focuses a lot more on recovering from error by being relaunched, rather than trying to cover every edge case and figure out how to recover from all sorts of different errors. So if some kind of the framework gets disconnected or some other unexpected thing happens, the whole thing's just going to crash, and the expectation is that something will restart it. That just gives you a lot more reliability in the end, and it makes things far simpler from a design standpoint. Now this is taking quite a bit of time, and I actually already have this file on disk. Oh boy. Looks like it's speeding up now. Great. So the Ceph-on-Mesos framework is a simple, it's written in Scala, it runs in the JVM, although it does require that you have libmesos available. Since I've installed Mesos on this host, it's going to be available as a part of the Mesos package that they offer. But it does require that. It uses the native Mesos framework driver in order to connect to Mesos itself. There's a variety of help options that you can provide it, or sorry, a variety of command line options. If you pass --help, it will list them for you. I've taken the liberty of deciding the ones that we want ahead of time here, just in the interest of time. A brief explanation. This parameter describes where to find the Mesos master. It uses Zookeeper for that, and it is important that you prefix it with zk:// so it knows that that's the intention. Also, we need to tell the framework where it should store its own state. Because I'm using Apache Curator to store the state, which maybe you have no idea what that means, and that's fine. Just know that you do need to make sure that you omit the zk:// for this argument. I might fix that in the future, but for now, that's the way it is. I don't like to put everything in the root of Zookeeper, so here I've actually specified /frameworks on the end. That's what's known as sort of like a chroot or like a jail. This just makes it so it's a little bit more organized for me. If you do something similar to this, and I recommend you do, you'll need to make sure that that node in Zookeeper is created prior to launching the framework, or it will crash. Then finally, we specify the public network. This is the network on which these VMs are running. Authentication. We authenticate against the Mesos master. And then the Mesos framework itself comes with an API and also a user interface that you can open. And we're going to tell it to launch on all interfaces, so I can access it from my laptop here. And also launch on that port. Okay, so let's go ahead and launch this. And if this is successful, we'll start to see offers come through. Now, if this doesn't work, if it fails to connect, there's a couple of reasons why it could fail. One of them is perhaps the default IP address, if you run hostname-i, is returning something that's not routable from other hosts. That would cause a problem. I've got this host configured properly such that it recognizes that its hostname is its exposed IP address, or at least an IP address at which it can be reached by its peers. So if hostname-i doesn't return a value that's routable from the peer other Mesos VMs, then that's going to cause some troubles for you. You can specify an IP address on which to launch it if you just specify libprocess_IP environment variable. If you export that prior to launching, it will use that IP address to advertise itself, and that will help resolve that potential issue. Okay, so we are launched properly. Oh, one other thing. Make sure that you have NTP installed on all of your hosts. If your clocks are out of sync, you'll have some issues connecting to Mesos as well. That should cover basic debugging and diagnosing. Hopefully you don't need any of that. Great, so we did launch. It's declining the offers right now. That's because we haven't told it to launch anything. Let's go ahead and get into the UI. Now this is running on Mesos 1 Dev Vagrant. I've told it to launch on port 8080. So here is the UI. Nothing terribly exciting at this point. We have a configuration tab. This allows us to edit and update the deployment configuration, and then dangling reservations. I do recommend you read about this and understand this concept, but we're not going to go into it right now. Prior to launching, though, prior to launching some resources, I wanted to show that the framework actually did a couple of things to initialize the state. One of the things it did is it created, of course, the deployment configuration. This is the default deployment configuration. It also generated some secrets. So these secrets are like the symmetric encryption keys that are used for the Ceph, various Ceph daemons to talk to each other and authenticate with each other. And then it also generated the file system ID that will be used. So the framework generated that all in, all in the process itself, and then it's just going to ship those values as it launches these containers. That was far simpler. It was far simpler to do that because it meant that now we don't need some external process like etcd to store and ship around the various configuration values. The framework can just take care of that for you. That's less dependencies, and overall I think that's going to work better for most people. Okay, so let's launch some monitors. I'm just going to go into the UI here and edit this configuration file and tell it to launch 3 monitors. And since we're in a VM and sort of a cramped space, I'm going to set these resources down a little bit. Disk type root is fine for monitors because monitors don't really use a lot of disk space, but they do need to persist some state that needs to live between launches. So I'm going to tell it to go ahead and allocate that persistent state on the root disk resource. And we'll just give it 16 megs. That should suffice. Now I'm going to hit save, and it's going to launch these right away. And you'll see it's going to only try to run one of them first, and then as soon as that one successfully launches, then it will launch the rest of them. That's just the necessary bootstrapping order to get a Ceph monitor cluster formed. Great, so these have launched. We should be able to oh, I need to be root to manipulate Docker, don't I? We should be able to get into one of these containers and check the status. And great. Yeah, we've got a health error because we don't have any object storage daemons. However, all of our monitors are up, and we appear to be in a good state so far. Wonderful. Now let's launch the Ceph object storage daemons. We're going to launch 3 of them. And again, I wouldn't set these resources this low. There's some good tuning recommendations. You can read about how much resources you should plan on assigning Ceph object storage daemons. But since we're in a VM and this is a demo, I'm just going to set it low. And we do want to use disk type mount as I specified before. Now there is a path constraint option, and you can read a little bit about it. There's a comment here which will explain more about it. But in effect, this is a mechanism you can use to tell Ceph to only launch on certain types of disks. Since Mesos presently doesn't have resource tagging, you can sort of use the path at which the mount exists to signal information about, oh, this is an SSD, or this is an XFS formatted SSD. So use that if it's not possible to be completely homogeneous on your disks and file systems and various properties. Okay, I'm going to hit save and come back over, and great, we've got another group here. OSDs are all set to be running. Now, this column here says the goal. The goal is that it is running, but the state is actually nothing, so it's not launched yet. I can click into that and expand it just with a simple mouse click, and see the current behavior. The behavior describes like where it is, where this specific job is in its life cycle. Right now it's telling us it's trying to match for a reservation, and it appears to be stuck here. There's a couple of reasons why it could be stuck, 2 of them in specific. The first reason is no offers are being made. The second one is the offers don't suffice. We can go ahead and look at the logs, which are outputted to standard error by default. So I'm going to go over to the terminal where I launched the Ceph framework and read through here, and we can see we do indeed have some offer not sufficient messages being logged. Could not satisfy request. Disk amount 512,000 with offered resources disk amount 1024. Aha! So we specified too large of a disk because that was the default. So to fix this, all we need to do is go into configuration again, go down to OSD. Here's where this value has been specified. I'm just going to lower it such that it will fit. Now, be advised, this is a minimum value. It will allocate anything, it will match anything that is larger than that. If you wish to put some kind of cap or an upper bound to make sure that you don't get too varying of disk sizes for your Ceph object storage daemons, you can specify an upper bound for matching using that parameter as well. But for this example, what the heck, why don't we do it? Feeling dangerous. I'll do 2,000. Okay, as soon as I hit save, that will apply immediately, and if you look at that, they matched right away. So that did resolve our resource matching issues. Great. Now let's go back over to our Docker container. Now I'm still inside of the Docker container. It's not entirely clear, but I did run this docker exec command, and I'm inside of one of the monitor containers. If I run ceph-s, I can see that we do have 3 OSDs launched, and we're good. Now, I didn't do any kind of configuration tuning, so we're going to get a lot of warnings throughout this. It's fine for a demo purpose. I'm just trying to show you how to use the framework in this video, and not specifically how to tune it into, how to tune Ceph more specifically. Although I will mention that inside of the deployment configuration, there's this settings block, and you can have full control over all of the values that are put into the Ceph configuration. The way this works is this section right here, like OSD, will map to like the OSD section in the Ceph configuration file. Here's the Ceph configuration file that the framework generated. And if you look at this, you'll be able to see that each of these values are just kind of mapped straight in there. Let's see, OSD max journal size. So they just sort of get inserted straight in there as you specify them. Okay, just a really quick overview of how configuration works. We have our OSDs launched now, and everything appears to be good except for our warnings, of course, but we're not going to worry about those for this demo. Now let's actually use the Ceph cluster. So in order to use Ceph in Docker, you'll need to install a Docker volume driver. There is one that I recommend, or at least I don't know if I recommend, but it works really well. So the Yellow Page folks actually started one, and it's a little bit stagnant. And then this gentleman, if you go into the graph here, network, this Porcupine gentleman has really taken this plugin on and pushed it quite further. And they have the most stable version he's released the most stable version that works the best. So you can install this and actually use Ceph with Docker. Okay, so that's sort of a little outside of the scope of this video, but I just wanted to show that really quick. So I mentioned, I don't know if I mentioned, I do have Mesos DNS installed. What Mesos DNS does is it allows us to discover Mesos tasks using DNS, and right here you can see that I'm actually able to ping the IP address, at least where the monitors are running, and it is using sort of a random round-robin DNS strategy. So I get a different IP address each time I resolve that. But it's important to note that the port on which the monitor runs, while it will be fixed once the thing is run, it won't necessarily be the same value across all the hosts. This is because it actually asks Mesos to assign it a port, and so it just takes whatever is the like minimum port value that's available at the time, and it reserves it, so it can have a guarantee that that port is open, so long as we have other processes that are not misbehaving and running on ports they shouldn't be. So Mesos DNS also comes with an HTTP API, which we can use to return these port values. Now, if I run curl against that, you'll see that I did get 31,000 assigned for each of them. And like I mentioned, you can't rely on this being the same, and you shouldn't. Although once it does launch, it will be the same from that point onward, but the port won't be the same across hosts. I hope that's really clear. So in order to make sense of this, we're just going to use JQ, which is a fantastic tool, to transform this into a comma delimited list of IP and port. Now, I'm using SaltStack to manage the Ceph framework itself. And in order for this to work, first of all, I'm going to have to go into one of the Ceph containers and pull out the file system ID, mon keyring value, and client admin. I'll just do that really quick. Docker exec-it, just punch into this one. And these values are see, ceph.conf will have the file system ID that got assigned. I could also pull these straight out of secrets. In fact, why don't I do that instead? That might be a little bit more useful instead of pulling it out of the Docker container. So get frameworks, secrets.json. Okay, so there's the file system ID. I need the mon keyring, which is that. And then I need the admin keyring. So this is just allowing me to specify some input values for the salt formula that I wrote to install Ceph on each of the hosts and create the Ceph configuration values. Now you can use Ansible or any other tool of your choice. I know Ansible is quite popular. I just chose Salt because I'm the most familiar with it and I like it. So here's my template. I actually use cat. I run a command, and the reason why I do that is so I can run this curl command and transform it through JQ and generate my IP and port list. Now, at a future point, I might make the framework able to do this, generate this file and return it. But right now, it's just this is a way to do it without needing to actually use the API for the framework. Okay, so there we go. I'm just going to go ahead and apply this framework. So I'll call status setup.ceph. And once this runs, it's going to pull the, oh wait, I actually ran this at an earlier date. So I need, I'm missing something. I need these two equal signs at the end of these. That's important. Sorry for that. Okay. Now that the configuration is deployed on the host itself, I can connect to the Ceph cluster without needing to be inside of Docker. And it sees the object storage daemons and the monitors. So we've succeeded there. Finally, why don't we create a image? Great. Let's map it so we get a device reference to it, put a file system on it, and then mount it. And there we go. We are inside of a Ceph volume that we have created and is being managed, or inside of the cluster, managed and deployed by the Ceph-on-Mesos framework. So, success. I hope this was useful. In a later video, I will be covering how to remove resources and some other administration tasks. Feel free to post issues that you have on the GitHub project, and I certainly hope that this is useful for you. Thanks for watching. Bye.